take for granted that when we turn on a faucet, fresh and safe drinking water will come out. But where does that water come from? And how does it get to our taps? And when it goes down the drain, where does it go? Hi, Alexi here from Opto 22. I'm here today in Waterford, Michigan to get some answers to these questions. The Waterford Township Department of Public Works has invited us here to show us how they treat and transport water to its over 74,000 residents. It's a highly automated system with advanced monitoring capabilities. In fact, it's got more technology than I've ever seen in a water and sewer district. So let's go take a look. I'm sitting here with Terry Biederman from Waterford Township's Department of Public Works. Terry, can you tell us a little bit about yourself?
Well, I'm the Director of Public Works for Waterford Township. It's a community that's about 35 miles northwest of Detroit. It's in Oakland County. We're responsible for 11 water treatment plants. We produce our own water. It comes from groundwater. We treat it and we pump it into the distribution system where we've got elevated tanks. And sewer-wise, we've got 62 sewer pumping stations, 350 miles of sewer main, and 360 miles or so of water main.
Very cool. You've got quite an elaborate alarming system. How many alarms do you have, and what happens with those alarms?
We alarm on over 1,200 different events, because none of our facilities, water or wastewater facilities, are manned 24 hours a day. For example, we've got a program in our control scheme using Opto 22. Basically, when an operator walks into a plant, a dialog box will pop up on the screen, and they've got to enter their password within 60 seconds. If they don't enter their password within 60 seconds, if that water plant's running, the program will shut the plant down, and we actually de-energize the motor control center. And then our people will get email notifications telling us that we've got an unacknowledged intrusion and that the pumps have been locked out so that they can respond accordingly. And all of our facilities have got ingress-egress monitoring, and it's all done through the Opto's equipment as well. If a door opens, our people, it'll get beamed back through the radio system, which then gets into the SCADA system and the alarming package, and it tells us what facility it is and what type of ingress-egress it is, whether it's an internal motion detector that got tripped or whether it was a door alarm. So we know at all times who's coming and going in the various facilities. We are currently using Opto 22 for everything in control and automation. When I came here as a director in 1996, I wrote specifications for a whole new SCADA system, and it was centered around the Opto application.
Wow, that's amazing. I understand you get calls from all over North America, from other municipalities, interested in what you're doing here in Waterford. What is it about your water and sewer systems that make it so unique?
Basically, I think where people see us a little differently than most other places is that the way that everything is integrated together. It's not one application. It's not SCADA's over here by itself, computer maintenance management's over here by itself, document management's over here by itself. Everything is integrated within one application. Our GIS application integrates document management, water modeling, sewer modeling. They never have to leave that environment. They can go in, they can create work orders in that environment, they can search on work orders in that environment, they can bring up customer files in that environment. So we can respond very quickly to our customers' needs, and we can give them accurate information a lot quicker than other communities can. We've also incorporated a broadband wireless network, which means our people basically are mobile, and they've got the same bandwidth that they would literally have sitting at the desk in their office in the field.
You also do things like monitoring pumps, how often they're turning on. Why do you do that?
Well, we monitor pumps on both water and wastewater. We monitor, obviously, if the pumps are running, power failures, station flooding conditions, communication failures, and all kinds of things. But more on the wastewater side, our sewer lift stations, because what we're doing is every day we reset them all at midnight. And what we're looking for is to make sure that the pumps are alternating the way that they're supposed to, and we look at the run times to make sure that the run times for each run are consistent with each other. For instance, if we've got a station that's got one pump has double amount of the run time as the other pump, we know that we've got a pump there that's probably either ragged up or some type of maintenance put on it, or it could have a bad impeller or whatever. So it's once again, it's proactive for us to go out and take care of that as opposed to reactive. You got a pump that's running twice as long as the other one. Well, that's a waste of energy.
So you've seen energy savings from that
Absolutely.
as well.
We've actually seen probably pretty substantial energy savings, keeping in mind that our system has grown from where in 1996 we could only produce 14 million gallons of water a day Today we're producing almost 30 million gallons of water a day. And then, of course, the energy costs that have increased probably doubled since then. So for only to go up $60,000 over 12 years with that kind of an increase, and that's due to everything from control systems to monitoring to putting in variable frequency drives and, a lot of energy management stuff. It's also saved us a tremendous amount of overtime because the system is really automated. What we're really doing is programming in a lot of our institutional knowledge into the processes at these facilities so that the programs themselves take care of a lot of the things.
So even though you're not a programmer, you like to play around with the software. What do you like about it?
Well, I love the flowchart programming. I mean, that's the way I learned to program as an engineer, and it's very basic, as opposed to, say, ladder logic, which, by the way, I can't believe anybody's using that anymore. But I mean, you can make it as complicated as you want, but it's also just its core very basic. You ask a question: is the wet well level greater than or equal to this level? And there's only two things that can happen: it's either yes or no. Yes, you're going to do this. No, you're going to do that, and then you just kind of cascade that through it. It's the way I think, basically.
So what were some of the key features that make Opto 22 such a good fit for your application and your needs?
Well, it's PC-based. The cost is less. It's more open architecture than really most other applications that I've played with. I've used Motorola systems. I've used Square D systems. I've used Fisher-Bailey systems. I've used Allen Bradley systems. And I really like Opto's flexibility. I like their backward compatible philosophy that I've got stuff that's been there 12 years. They all talk, they all work, they're very reliable, and so yeah, my overall satisfaction is I'm very happy with it.
Right. Thanks for talking with us, Terry, and thank you for watching the video. For more information about this application, visit opto22.com. See you next time.